Hello. As we have seen in our previous lessons, we had gone through introduction and we now knew what's the differences between each block type we have. We have seen the organization blocks, we have seen the function blocks, we have seen the data block and user-defined data type and the variable tables, and we already got many examples of each block. So this is a introduction. This is the basics of Siemens. We need to know what the difference between each type of this block. Now we want to go much deeper into the programming language. We need to write some code. We need to know how to write a program. To do so, we usually do it on any of the functions as we have seen before. So if you open any one we have created, like FC1, and then collapse the network and then create a new network. So we need to write some code into each network of these. And to write the code we have some elements, we have some programming elements. These programming elements is used or is categorized are categorized in this type of elements. We have bit logic, comparator, converter, counters, data block call, jumps, integer function, floating point function, move, program control, shift, rotate, status bit, timers, word, and many other blocks. We will not go through each type of these programming elements because it needs like many hours. We'll go through for the element that are most common elements. So we'll start first with the bit logic. The bit logic here, we have some symbols as we see here. Each one represents something, and for the ease of use, these symbols, some of them already repeated here on that toolbar. So if we the first one is that one, this symbol. If we hit F1, which is the help, if you don't know any element what that element does, just hit F1. So F1, this says normally open contact, and if we drag that one and hit F1, it says normally closed contact. And then if we put that coil here and hit F1 again, it will say output coil. So that means this is normally closed and this is normally open, and that's the coil. What that logic means: if this one is true, if this one is on, and this one is false, which is off, this coil will be energized. So this is a very simple logic, and then we can assign some tags into this logic. So you see here, this is an AND gate. That and that will result in that. But we can put in the same network here an OR gate. How can we do this? If we click here and then click here and then add another AND, double click and then hit here and then that arrow up, or we can arrow up. That means that if that one is true, or that one is true, and that one is false, will energize the coil. We can make it much easier, not much easier, we can have another representation of that ladder in a function block. If you go to view and then click FBD, function block diagram, it says one or more address were not filled in. Answer, you have to fill it in first. Okay, I'll put M3.1 just for test some tags, random tags, M3.2, and then M3.3, and then we'll have M3.4. Okay, there is no error. Okay, so and then I will have function block diagram. So you see here this ladder converted to a function block. So this symbol is OR gate, and that symbol is and this is inverted, the same as M3.3 should be 0 to have M3.4 equal 1. If you go back to the ladder, so M3.3, so we can the same. This is a beautiful thing in Siemens, that the same logic you have written, you can see it in a ladder or in a function block diagram. This is not applying, just for your knowledge, this is not applying for each type of coding, but this applies for 99% of the logic that can be seen in different programming language. Just you can toggle between ladder, statement list, function block diagram. So this is very simple logic. This is how we write it. So we now know what's the difference. We go back to the ladder. Okay, so now we know what's the difference between this one and that one and that one. I'll just go through the most common one. I will not go through each type of element. Okay, then we'll have we'll then go through this R, S, R, S, S, R. Okay, R, what is the R? R is the reset. So if we replace M3 point instead of coil, this is coil, usually energized or de-energized, depends on the logic behind. But if we replace that one with the R, I will delete this one and put reset. I'll make M3.4. So M3.4 in that case will be reset, will be 0. There is no way to set it in that logic. If this logic is true, the M3.4 will be reset. M3.4 will be 0. This is the reset. And if I replace the reset instead of set, I'll say M3.4 set. That means if the logic is true, M3.4 will be 1. If this logic is false, nothing happened to M3.4 because it's already set. So usually the rule is once you have a set, you should have a reset. Otherwise, that bit will be always true in our example here. Once that logic is true, M3.4 will be always true. There is no way to reset M3.4 unless you have another logic with a reset command. To avoid this conflict between each one had a set and each one has another reset, you can use SR or RS. We can create another network. We can use RS. So this RS, I can say M3.5. This is the address. We have used that one before. Okay, M3.9. Okay. It's not called M3.9. Okay, M4.0 and this M4.1. And then I put a logic here just before that one. I'll say M4.2. So that means if M4.2 equal 1, M4.0 will be 0 because this is the reset command. If M4.1 equal 1, so M4.0 equal 1. This is RS. We can use RS or SR. What's the difference? RS in Siemens programming language, only in Siemens, because in other programming, in other controllers, it's a little bit different. But here in Siemens, the RS is the RS. If using the RS, the R, the S is the dominant, and the SR, the R is the dominant, which means RS, S is the dominant, means if M4.2 equal 1 and M4.1 equal 1, both equal 1, so I'm asking that RS to have reset and set. I should have one of them dominant. So in RS, the dominant is the S, the set. So if both are true, M4.0 will be true. That if I'm using the RS. What if I'm using the SR? Keep this one expanded. The SR. just click here, the SR. I'll use another tags, M5.0, M5.1, and M5.2. So this is the SR. If both are true, the reset will be dominant. So if both are true, M5.0 will be 0. Okay, so the dominant is the one at the bottom here. This is the dominant. So here this is the dominant and this one is the dominant. So if if both are true, so the dominant is set, so for M4.0 will be 1. If both here are true, M5.0 will be 0. Okay, so this is the set, reset, normally open, normally close, and the coil. Another important element is the N and the P. What's the N and what is the P? Okay, N is coming from negative and P coming from positive. Actually, is the negative edge and the positive edge. So that means if I put here just after M5.1, I'll just put here after 4.2, I'll put positive edge, and I will rename it to be M4.5. Okay, so that means if that logic only applies at the positive edge end of M4.2. So if it's going, it's moving from 1 to 0, it will apply. But if it moves from 0 from 0 to 1, it will apply. If moving from 1 to 0, it will not apply. It only detects the positive edge. And the other way around, N, which is the negative edge. The other way on negative edge, which is if M5.1 is moving from 1 to 0, so that we have a negative edge, this will reset. And if this moving from 4.2 from 0 to 1 as a transition, this will be reset. So here it detects only the positive edge and this only detects the negative edge. This is a very useful tool when you do a programming for some certain application. So it's very, very useful. So we've already done the bit logic. We just explained the most common elements. You can investigate much more what the others means. What this one is very useful as well. This is like a state. This one is useful. You can use it to know what that each one of these means. You just click on it and hit F1, which is the help. This one is called midline output. You will go through this application, you will know what that means. And another one, which is a NOT. Here, if you click here, NOT which is inverted. If you hit one, you will see invert power flow, which is inverted. So it's very easy and very common ones as well. So it's but we already explained the most common one, and you can know more if you just search and look for it. Thank you.